Okay, guys, we're back for these last two examples in your notes. Okay, so we wrote equations of lines once we were given the slope and y-intercept. We wrote equations of lines when we had a picture of a line. We wrote the equation of a line when we were given just some random point. And we wrote the equation of the line when we were given 2 points. Okay, so here, well, we were actually given the line with 2 points. This isn't much different. We're given 2 points on the line, right? So again, guys, sometimes it's nice just to go off to the side and a real quick sketch. Look at this. 3, 1 is very rough, right? 2, -3. The reason I do that is it at least helps me to know, okay, I should be having a positive slope. My y-intercept should be something really negative. Okay, it just gives me that idea, that glance at what this line should look like in case I make an arithmetic error. So first I'm going to find the slope. I'm going to subtract the y-coordinates. 1 minus -3 divided by what I get when I subtract the x-coordinates. 3 minus 2. So that gives me 4 over 1. So my slope is 4. That kind of looks like a steep slope of 4, doesn't it? If you would have gone the other way, guys, don't worry about which order you pick the points. You'll get the same answer. If I would have, instead of doing 1 minus -3, maybe I do -3 minus 1. The only difference is now, since I started with this point for my y's, I start with this point for my x's as well. And I'll take 2 minus this x of 3. So that gives me -4 over -1. Well, that's still 4. Okay, so we get the slope of 4. Now we pick a point. And like I showed you on the last slide, it doesn't matter which point we pick. I'm going to pick 3, 1, and I'm going to use my point slope form. I'm going to take y minus, let's see, the y coordinate up here is 1, equals slope, which I just got as 4, times x minus, let's see, the x coordinate that goes with 1 is 3. Rewrite it in slope-intercept form, so I will distribute my 4 through. 4 times x is 4x, 4 times 3 is 12, and then I'll add 1 to the -12. I get y equals 4x minus 11. I knew this was going to be a, far down negative y-intercept, so that kind of makes sense here. Y equals 4x minus 11, slope-intercept form. Yay. Okay, so remember that. Y equals 4x minus 11. I'm going to do it the other way too to show you get the same thing. I'm going to choose the other point. So I'm going to take y minus the y coordinate of -3 equals slope of 4 times x minus the x coordinate of 2. Minus a negative is plus, so I'll write y plus 3. I'll distribute my 4 through, giving me 4x minus 8. I'll subtract, that didn't look like a 3, did it? I'll subtract 3, and I get y equals 4x. Let's see, -8 minus 3 is -11. Same answer, y equals 4x minus 11. Okay? Doesn't matter which point you pick. All right, here's another example. Again, I usually go off to the side. -2, -4. And 3, 0. Oh, they're giving me the x-intercept, not the y-intercept, but oh well. Okay, so this should have a positive slope too, and my y-intercept should be -2.5-ish. I don't know. It depends. I didn't draw that perfectly, but anyway, gives me an idea. I'm going to subtract my y coordinates. I'm going to take -4 minus 0, divided by what I get when I subtract my x coordinates. -2 minus 3. So that'll give me a -4 over -5. Well, that's 4/5. Okay, a negative over a negative is positive. Don't keep that double negative there. That will drive you crazy and make you make a mistake. A negative divided by a negative is a positive. So I have a positive 4/5. All right, guys, you see now that you can pick either point. I did it over here with both. I usually pick the point that makes me confident that I might not make as many errors. Okay, so I don't like to pick lots of negatives. 3, 0 looks like an easier point to pick. So that's what I'm going to pick. Y minus the y coordinate of 0 equals slope of 4/5 times x minus the x coordinate of 3. I'll distribute y minus 0. Well, that's just y. So I have y equals 4/5 x minus 4/5 times 3 is 12/5. Don't take the 4/5 times 3. You just take 4 times 3, not the 5 times 3, okay? It's 4/5 times 3 over 1. That's 12 over 5, okay? Oh, sugars, they want it in standard form. I didn't notice that. Standard form is ax plus by equals c. So they want my x's and y's over here. I'm going to have to subtract the 4/5 x to both sides, giving me negative 4/5 x plus y equals negative 12/5. Well, that's super, but I mean, I got my x and y over there, which I'm glad about. However, a has to be positive, first of all, and a, b, and c aren't supposed to be fractions or integers. So I'm going to have to multiply by 5, but to make sure I get rid of this negative, I'm also going to multiply by a negative. I'm going to multiply everything by negative 5. Okay, that gives me a positive 20 over 5, which is 4x. Negative 5 times y is negative 5y. Negative 5 times negative 12/5 is positive 12. Remember, we don't care if y is negative or if this constant is negative. We just can't have a negative a. So in standard form, we get 4x minus 5y equals 12. All right? Okay, let's try the last example, parallel and perpendicular. Remember, parallel lines have the same slope. We learned that last chapter. Parallel lines, or last section, have the same slope. Do you remember about perpendicular lines, what they have? Perpendicular lines have opposite reciprocal slopes. Okay, so if one slope is 4/5, if one slope is 4/5, the other slope is negative 5/4. So what I mean by opposite reciprocals. They're opposite signs, and they're also flipped. So I want a line that's parallel to this line, but goes through the point negative 1/6. So when they tell me that my line is going to be parallel to this line, I know that my line has to have the exact same slope. All right, well, the slope of this line, y equals 2x plus 1, that's in my slope-intercept form of mx plus b. So I know that the slope is 2 of this line. Well, if the slope of this line's 2 and my line's parallel to it, the slope of my line is also going to be 2. The slope of the given line is 2. The slope of my line's 2. All right, and then I'll use point slope form, which was y minus the y coordinate equals slope times x minus the x coordinate. So my y coordinate is 6. My x coordinate is negative 1. So I'm going to write y minus 6 equals the slope of 2 times x minus negative 1. That gives me y minus 6 equals 2 times x plus 1. Distributing my 2 through, I get 2x plus 2. And then I'll add 6 to this 2 and get y equals 2x plus 8. Okay? So y equals 2x plus 8 is parallel to y equals 2x plus 1, and it goes through negative 1/6. Same question, only this time it says perpendicular to y equals 2x plus 1 and going through negative 1, 6. The slope of the given line is still 2, but the slope of the line I want is the opposite. Okay, so since this is positive, my slope's going to be negative, and I flip 2. 2 is 2 over 1, so if I flip that, it's 1 over 2. So I'm going to do the same thing I did over here. I'm going to use my point slope form. Such a great form. It helps me find the slope intercept form. I'm going to write y minus the y coordinate of 6, just like I did over here. The only difference is instead of using 2 as the slope, I'm going to use negative a half times x minus the x coordinate of negative 1, just like I did over there. Okay, so very similar. It's just a different slope. I'm going to change minus and negative to plus, just like I did here. I'm going to have to distribute my negative a half through. Negative a half x minus a half. And then I'm going to add 6 to the negative a half. It's not so fun, huh? Add 6 to negative a half. That'll be, what, 5.5? Oopsies, I forgot my x. Y equals negative a half x plus 5.5. If I add 6 to both sides here, I get y equals negative a half x plus 5.5. All right, this is perpendicular to this line, and it goes through the point negative 1, 6. Okay, so that is it for the examples. Good luck with the homework. Come back to this, whatever the question is, you should be able to find something similar here in the video that you can maybe fast forward to or whatever and try to understand. Okay? Look forward to seeing you in class, guys. Have a safe week. Bye.